Well, actually, you should record to your computer so that you can then process it. Otherwise,
And I'm actually going to start recording again. And then Henry's going to take 20-25 minutes to describe the strategic pathways and why they are the pathways by giving you examples and give you a chance to ask any questions. Then he'll introduce the tool or the model itself and take 10 minutes just visually showing you by sharing his screen what it looks like to use it. Then what we'd like to do is if you're at your computer and you took a moment and already opened the tool and it's on your computer, we'd like you to play with it so that you can then ask questions in the last 10 minutes to see how the heck does this work and whether or not you want to sign up for your own tutorial. So that's the flow of the evening. And I see some other people have joined us, so I want to acknowledge you. Thank you for coming. And I'm going to share my screen now. And I'm just going to share. Right.
Context of municipal clean energy planning.
So I'm going to ask everybody just to mute themselves while I'm presenting and Henry's presenting, and then we'll unmute when it's time for questions. My goal here tonight is just to say, we know that there are many causes of climate change. And our focus through the Ready for 100 campaign has specifically been on the transition from fossil fuels. But we know there are many others. And the, can I move this? When you see my screen, do you see yourselves in the corner or do you just see my slide? Okay, so I'm moving that over.
We see your full screen.
Okay, so I'm not sure how to, I think I can just shrink it. Yes, okay. So the project called the Drawdown Project did an analysis of all the possible solutions, and they came up with a chart that I think more or less captures universal agreement that the current sources of our problem fall into a number of categories. So it's not an infinite number and it's easy to define. And electricity production is a quarter of it. Our food and agricultural system and the way we use land is another, more or less a quarter. Industry and the production of goods is about 21%. And then transportation, buildings, and other related are under 20%. But if you add up transportation and buildings and add them to electricity, which are an industry as well, they're the heavy use of fossil fuels. They think about it in three categories: that we can reduce the sources, and the row on top are the major areas we just discussed, and the circles are the perimeter is the potential we have in terms of impact, and the darker circle is the range. So we could definitely get to the perimeter of the inner circle, and we'd like to get to beyond, and they're relative sizes. So electricity would have the biggest impact, as you can see, and so forth. The other thing that they look at is, are there ways to capture carbon, which they call supporting sinks? And then their third element is improving society. What are going to be the specific, concrete social, educational, and health benefits, but also how could we use education as a tool? So the Drawdown Project is looking at two scenarios: staying within the 2 degrees, which was the original set of guardrails set by the international community before we understood especially about methane, and the 1.5 degree temperature is scenario 2. So in the charts I'm about to show you, I have 3 or 4 charts to show you. The 2 columns on the right, the first column is scenario 1 and scenario 2 is the one on the right. And the numbers represent the gigaton equivalent that we could reduce if we went full force on these solutions. So they rank the top 10 that would have the biggest impact from their point of view. What would be the highest reduction for greenhouse gas emissions? So you'll notice that number 2 is wind turbines, so that's renewable energy. And number 8 is solar farms, which is larger scale. And rooftop solar which is the residential or local businesses putting it on. So in the top 10, 3 of them are the production of renewable energy, which is our topic. We're going to be breaking it up into 3 categories, similar to the ones they use. Our focus is going to be on efficiency. Those will be the first 2 weeks we'll be working on efficiency. And you can see on the right-hand side, the columns say scenario 1, which is to 2 degrees. And the more ambitious one is scenario 2, getting us to 1.5. And you can see that insulation has the highest impact in compared to all of them, but they are all important. And they're the things that we actually tangibly can influence. The next one is the electricity sector, which they include lighting in. I would have put lighting in efficiency. But if you look here, the biggest impacts, as predicted, as we saw earlier, are onshore wind turbines, utility scale solar, distributed solar, and offshore wind. Those will have the biggest impact, as well as concentrated solar in both scenarios. And then in transportation, the things that make most difference are really spread across almost all of these choices. But shifting to electric vehicles, and whether it's trains or trucks or cars, are going to have, those are the choices that will have the highest impact, but they all contribute. I wanted to do that as an initial introduction, just to reinforce what we will continue to reinforce, which is that there are, in the fossil fuel category, reducing emissions will include efficiency, the electrification of the system, and the electrification of transportation and our buildings. So I'm going to turn it over to Henry and ask him if he will share his screen, and he'll spend some time talking more about these as specific pathways that we'll be looking at our concrete choices for. And then we'll look at the model that will help you play with what happens if I increase our clean grid, but I don't get any electric cars, or vice versa. So I'm turning it over to Henry with deep gratitude for the skills and knowledge that he brought to bear to put this tool together for us.
Well, thank you, Paula. The drawdown is a very useful document, and talks about a lot of the overarching approaches to climate control. And what I'm going to concentrate here on is can you see the screen there?
Not yet.
Okay.
Just you.
Okay. I've never been very good at this. Let's see what we can do.
While you're bringing that up, I have a question, Henry and/or Paula. One of your slides showed like one of the big contributors that would help would be educating girls. And could you speak to that a little bit? I mean, I think it's kind of like because they're consumers. Is that what you mean? Is that what that means? What does that mean?
For about 4 decades now, there's been a lot of work in international development on the impact of programming specifically to support girls and girls' education in terms of economic development as well as social development.
You mean worldwide, not so much.
Worldwide. So we're thinking of developing countries where girls often don't have access to education, where there's still a pretty strong patriarchal system in place. And Henry, when you're ready, just say so and I'll continue this later. So the international development research has been totally conclusive that when you invest in girls and girls' education and women and women's empowerment in the marketplace.
I was thinking all those slides were pertaining to the U.S. only, not so. That's really
no, these are global.
Global, okay.
Global, yeah.
Okay, I'm ready.
Okay.
Could I
Sue asked a question. Will we get these slides? Will we get copies of all the
Yeah,
slides?
they're going to be put in the folder. I've created a folder within the folder, and I'll show you where it is before we get off tonight.
Okay, the set of slides I was looking for was below. I had to scroll down. I didn't know that you would have to do that. Okay, this covers the strategy for energy transition and greenhouse gas reduction in the suburban townships and boroughs of Pennsylvania, and is more specific. Doesn't have a lot. We don't have a lot of agriculture, a lot of land emissions from land. What we have is emissions from what you would consider a typical urban suburban area. What I'm going to discuss when I get to the end of this presentation is what it would mean for the Westchester area to achieve emission reductions. Westchester area has a population of about 101,000 people, 38,000 housing units, about 73,500 automobiles, and buy about 5,000 new cars a year. And so we figure in red here what would be the impact on the Westchester area. But first of all, let me go through the slides having to do with the model. First of all, how do you determine emissions of greenhouse gases for which we're responsible? You develop an emission inventory. And that tells you who emits greenhouse gases and how much they emit. It's broken down into the following sectors: residential, commercial, industrial, mobile highway, mobile rail transit, and you can read the rest down there. This is a typical breakdown for the suburban area of Philadelphia. You'll notice that the residential blue, the commercial and industrial in red, and the highway in green constitutes about 95% of the emissions, and most of the rest comes from solid waste, which is the light blue. In southeastern Pennsylvania area, the best and most recent greenhouse gas emission inventory is the 2015 DVRPC emission inventory. That's the Delaware Valley Regional Planning Commission. And as I said, about 95% of the emissions are from buildings, residential and commercial, industrial, and transportation. This gives you a much better view of all the information that's provided by the emission inventory. So let us go now into the residential sector and take a look at that. You have new houses. You can do more with new houses. And with existing houses, what you have is what you've got to work with. In new houses, you can have passive cooling and heating. You can have triple pane glass, higher R-value insulation, and tight construction, so there are no there's minimal air leakage, and energy star appliances from the get-go, and that can get you 45% reduction in the usage of energy when compared to the average house today, with little additional cost, and which is more than made up by energy savings. On existing houses, there are a lot of things that you can do to tighten up existing houses so that they leak less. You can insulate them. You can buy Energy Star equipment when you buy a refrigerator or a heater, and make sure that you get the most efficient energy usage within your home. And that can increase your efficiency by as much as 24% for thermal efficiency, that is insulation and weatherization, and electrical efficiency within the house. Finally, you can electrify your house by converting to heat pumps when your natural gas, propane, or oil heater needs to be replaced. Electric heat pumps are 3 times as efficient as oil or gas. So this gives you a set of strategies for highly efficient replacement housing or for thermal efficiency, electrical efficiency, or replacement with heat pumps within existing houses. So if you start with residential, you have business as usual. This is what you get from replacement building efficiency, that is, new houses being more efficient. Adding existing building efficiencies on top of that will further decrease the emissions. Adding heat pumps for fuel oil and propane and for natural gas will further decrease emissions. And finally, as you have electrified your house and turn it over to electricity, as the renewable energy progressively replaces the fossil fuels in generating electricity, you get a cessation of emissions over the period between 2019 and 2050, all with technology which is available today, much of which will be will be as cheap, or some of which will save you some money. Some will be more expensive. The same thing can be said of commercial and industrial buildings. The only difference here is that commercial and industrial buildings either get torn down or rehabbed much more frequently than houses. And so the rate at which there's turnover to more highly efficient new systems would be 1% rather than 0.5%. And I believe that that is a conservative estimate. Business as usual, replacement of building, replacement building efficiency, adding existing building efficiencies, adding heat pumps, and finally, the conversion over the period between 2019 and 2015 to renewable electricity at the rate of about 2.3% per year. Move on to cars and light-duty trucks. There are 3 ways to reduce emissions from cars and light-duty trucks. The first way is to reduce vehicle miles of travel or reduce trips. This is done through increasing public transit, the availability of it, and decreasing trips, eliminating trips through telecommuting, which we're all now very familiar with. You can imagine if we all got together tonight someplace for a presentation, how many more trips there would be in a year because of that. The second way is to increase the mileage per gallon for internal combustion engines as they are phased out. Still has a significant impact. And the third is a 3.5% per year conversion to an electric fleet of cars. This gives you the strategies for cars and light-duty trucks. Again, business as usual. Cars and light-duty trucks being replaced by mass transit, and a vehicle of trip elimination, reduction of VMT, an increase in the mileage of the fleet of internal combustion engine cars, the conversion to electric vehicles, and finally the cleanup of the electric grid, which would run vehicle transportation. Medium duty and heavy duty trucks. The Union of Concerned Scientists has done a literature review and has shown that you can achieve a 50% reduction by improvements in engines and drivetrains, aerodynamics, and wheel and tire design. And the use of hydrogen as fuel could achieve another 50% reduction. That is another 25% overall. Also, Tesla has come out with a very attractive electric vehicle for heavy duty, long haul trucks. The reduction there can be about 75% for medium duty and heavy duty trucks. Then your other sources, remember they're only about 5%. Rail transit can be converted to electric powered locomotives. This area has very little agriculture, and especially most of the municipalities that we're working, that you're involved with, have almost insignificant emissions from agriculture. Natural gas systems, which are used to obtain and distribute the natural gas, would reduce at the same 5.4% rate that the usage in residential would achieve, along with the industry. Waste management strategies would be composting, recycling, and landfill gas recovery. Wastewater, haven't spent a lot of time looking at that. There are ways to reduce emissions, but you will have a certain amount of emissions from wastewater. And industrial processes, there are technologies being evolved for that. However, this is a listing of all the technologies, all the industries in the five county area which have emissions which aren't already included either as solid waste or electrical generation. And the only township that is involved in this seminar series that has emissions, process source emissions from industry is Plymouth Township. And it has the very large Covanta waste to energy incinerator and a ArcelorMittal plate, steel plate manufacturing facility. And these are significant sources in that area. But other than that, there is almost no industrial process in those townships and boroughs. This 5% is reduced significantly by technologically capable ways of doing it. Now, all of that that we've covered so far is simply efficiency, either implementing building energy efficiency standards, increasing the miles per gallon for internal combustion engine cars, or conversion of electric vehicles. and control of medium duty and heavy duty vehicles and other small sources. And that gives you 50% reduction right there, even before you green the grid. So let's take a look next at greening the grid. First of all, what happens when you add all the electric for running the electric vehicles and for the heat pumps to eliminate gas and oil, natural gas and oil in buildings? That's offset by the efficiency, as you'll see in the green and the brown lines to below. And the result is that if they're assuming no growth, and this is all a no growth model, you will have a 3.6% decrease in electrical demand. You'll still have the same demand, but it's going to be redirected and to more efficient processes. Now, if there's a 25% growth in the area, then you'll have a 25% growth in the electrical demand. But I'll show you below, you will not have any significant increase in the emissions. The rest of the greenhouse gas emission reduction comes from the transition of electricity generation to renewable energy. And this will be accomplished through solar and wind buffered through electrical storage. For solar, you have either rooftop solar, ground-mounted solar, or utility solar. And utility is the most efficient way to go, but rooftop and ground-mounted solar are still important. The other major source of electricity would be wind energy. The NREL, or National Renewable Energy Laboratory, has shown that the U.S. has over 4,000 gigawatts of potential offshore wind power, which is about 4 times the amount that is needed for capacity. And so this is, there is abundant source of wind out there. A great deal of it is on the continental shelf of the mid-Atlantic. Finally, energy storage can buffer the wind and solar usage to achieve reliable energy overall throughout the day. The result is with reliable renewable energy, you can have the following reduction in emissions of greenhouse gases. And if you had a 25% reduction in increase in electricity, because there's a 25% increase in the growth of an area, it's not going to have very much effect on this little area in 2050. Finally, I want to get back to our example, and that is the Westchester area. What would be the impact of these various changes if you have a participation rate of 0.5% for houses, that is replacement housing stock, the quantity, the number of housing units that is involved per year would be 188 housing units. If you have an increase in electrical efficiency through Energy Star replacing on a constant basis the lighting and the appliances in our houses. That means it would be the equivalent of 1,505 housing units out of 38,000 a year having new appliances. Now, of course, everybody's going to be getting their appliances when they fail, but that means that once every 25 years, if there's a turnover at 4%, you have an entire turnover in 25 years, and you have achieved an overall 24% reduction. So you can look down through here, for instance, with a 3.5% conversion to electric vehicles. You will have, out of the 5,000 new cars purchased per year, you'll have 2,650 that are electric vehicles. These are the types of changes which would be needed in order to achieve the rate that we're talking about. And all of this is doable if we set our minds to it and decide that we want to carry this out. So that's the end of that presentation. Are there?
I have a question about that graph you just had up.
Yes.
The housing stock, first line.
Yes.
5% new housing stock results in 45% reduction?
0.5%.
Yeah, 0.5%.
188 houses that would be, this is replacement houses.
Oh, okay. Not 45% overall over the whole housing stock in the.
No, this would be for those houses, you would achieve
Understood.
5% reduction in those houses.
Got it. Okay.
Any other questions at this time?
I have a question. So does your strategy look at very built out communities versus communities that are not that populated but have a lot of, maybe I'm jumping ahead, but have a lot of growth for expansion that are anticipating new construction of residential?
Well, it would cover, let me figure how I could answer that. Whatever is built, it's assumed that it will be built to the new standards. And the impact on the emissions would be insignificant because you're talking about, when you get to this point, even if you've doubled the, even if you expanded by 100%, you'd only be up to here. Some areas are going to expand, others are going to contract. And it will even out with between those that expand, those contract. And if you have a national increase in building over the 30-year period of maybe 30%, it will not have that much of an impact on the overall emissions in 2050. That's a good question. Does that answer your question there?
I think I understand where you're going with this. I mean, you had made a statement earlier that new construction has the potential to reduce emissions. I think, was it 50%? And then existing buildings or residential is like 24%. But
45% and 24, yes.
Yeah, I think it was something like that. I see where you're going with this. Okay.
I think the other answer to that question, Henry, is that when we get to the model, which is what we're about to do, the models that we sent you are for your communities. So if your community is not going to be building out, then you will not be putting in the formula or the strategy that you would for a community that is. So for example, the Extons of the world, Euclid and the West Whitelands of the world, they would put in, based on what they know about their community, that they're going to be putting in more. They would put a higher emphasis maybe when he shows you how to do this on new construction, whereas a township that's really built out and it's replacement housing, it might follow the conventional formula that he's sharing. So you have control over what you put in.
Is this something that we should each talk to our planning department to get an understanding of? I mean,
That
I
would
would
make
think.
sense.
Let me say it one other way. I put into this model here a 1.5% increase in the growth, 1.5% growth per year, as opposed to 0%. And it hardly changed the shape. I ran it both ways, printed them out, and I had to look very carefully to see a difference. Now, let me just describe to you a little bit concerning the model, and then you can play with it yourself and get a feel for what makes a change and what doesn't make a change. For instance, okay, I should say that this is the building energy standards area.
Can you make it larger, Henry,
Yeah,
please?
let's see. Is that large enough? Okay, here is the residential area, commercial and industrial strategies, mobile source strategies, and strategies for non-energy greenhouse gas emissions based on the DVRPC information. And finally, here is the impact of fuel switching in buildings for natural gas and residential and commercial oil and propane usage. And here is the part having to do with renewable energy. And let's just take a look here. If you did not replace fossil fuels at 3.2% per year with renewable energy, let's say you decided that we're not going to do that, then it shows you here what the impact of reducing the rate at which you go to renewable energy. So that is basically the same as this graph, which just shows you the impact of energy standards and conversion to increase in efficiency. So we'll make this up to 3.2, as we hope it will occur. And then let's look at the increase, the reduction in, let's see. Let's look at the conversion to electric vehicles. And we'll take that down to 0. That increases quite a bit there. And as you can see, the motor vehicle portion is reduced somewhat through trip elimination and through increased mileage standards on internal combustion engines. But even if you take that out, you'll see that there's very little difference at all. The difference would be in the improvement of public transit and the reduction of trips. So you can play with the model and increase or decrease the percentage of the change in strategies in whatever way you wish to do so, and you'll see what the impact will be on the emissions from efficiency and the added impact of the strategies to convert to renewable energy. Are there any questions concerning that?
Henry,
I'll make a comment.
It seems that some of the participation rates are fixed and some are variable. What is the difference? I'm sorry if I cut somebody off.
No, that's, well, for instance, participation rate here is, say, 3.5% for electric cars. You either have an electric car there or you don't. So the participation rate when you get an electric car is the electric car. Here, it's a question of what percentage of the buildings participate per year. And then you can also vary what percentage do you think that they're going to be able to reduce if they participate. For instance, some heating and air conditioning person may say, oh, I don't think you can get 24% reduction. I think you can only get 20% reduction. So you say, okay, let's put in 20%. You can see that it doesn't make too much difference. Now, if you decrease the participation rate, you can see the difference. So toggling some of these changes will make a bigger difference than others. Other questions?
Yeah, I'll make a comment here. So I love all this wonky stuff, and it's critical to know this. But in the end, there's priorities, and there's a very, very strange relationship between electrification and efficiency. In all cases, when we talk about electrification, we make the assumption that renewable energy will supply that electricity. And I think that is a good way to think and a good way to go. The one thing that is very, very difficult to talk about with regard to priorities to our stakeholders is efficiency, and especially thermal efficiency, more important than electrification? And I would, I'm getting excited to play with your calculator here, because I am expecting that if you were to eliminate, and what we don't have here, of course, is investment, but anybody that has a house knows how hard it is to increase thermal efficiency. So this is a tough nut to communicate, because everybody knows it's the right thing to do. But in the end, the dollar spent between getting a heat pump and using more renewable energy, making the assumption that's always good, and obviously that's arguable, versus getting insulation and new windows, is a really tough analysis that I think we should go after. With regard to messaging, I always just say this. There's three things you can do. One, buy renewable energy. That's 30% of your greenhouse gas. Two, get an electric vehicle. That's another 30%. You're already over the 50%. And then for the last 40%, go for electrification. I know that leaves a lot on the table relative to the granular work that we're doing here about rail transit and 150 other variables. But that's how I always boil it down, even though I love wonking out with all of these charts and think it's important. But in the end, the messaging at the top level is, you know, what we need to work on, because most people would choke on this data.
Well, I understand that. And I appreciate what you're saying on that. I've also run a fair amount of cost effectiveness of various strategies. And it's very interesting to get into what is really cost effective. Efficiency is probably the most cost effective thing you can do. A plug-in hybrid electric car right now may be more, maybe a better way to go for a lot of people than an electric car. It depends. So these are choices that you need to make. And these are the things that we need to noodle through as we go forward. But these are the strategies. There are no other strategies than these. These are the strategies that you have in the suburban Philadelphia area to reduce the emissions within the municipality. Now, there's a whole different set of emissions that are tied to your personal consumption. And this does not, which are significant. This does not deal with personal consumption to a reasonable extent. But what we're charged with right here is to say, what can we do to reduce and eliminate the emissions of greenhouse gases that are emitted within our municipalities? And that's what I see that we're charged to do.
Neil, go ahead.
Yeah.
Neil and then Jackie.
Okay. First of all, Henry, this is great. I think this tool is going to be tremendous help in, even if it's just a very generalized understanding, but I think it can get pretty specific here. The question, yeah, I'm sure. Looks like it. I have a quick question about this. Does the modeling take into account the upstream consumption and greenhouse gas emissions? So, for example, in building a new house, tremendous amount of energy goes into all the materials, the transportation of stuff to the site, all of that. There's a tremendous amount of investment in terms of energy consumption and greenhouse gas emission just in that process, not even talking about how much energy the house is going to use. And so I'm wondering if those sorts of calculations are built into this, or if that's sort of on the side for the time being.
No, they're not. There are two different types of emission inventories. There's a geographic emission inventory, and there's the consumption emission inventory. And they're quite different.
All right.
They overlap, but you can have consumption being another 40 or 50% of the emissions of an area over and above the geographic emissions
Right.
that we're dealing with here.
Okay.
They are personal consumption issues, from the steel that comes in to build the house, the wood that comes in, the plastic that comes in that wraps the cheese in your refrigerator, the refrigerator itself, which is hopefully built in Milwaukee and is shipped to you. There's a great deal that needs to be considered there. But this is just, what are the emissions within our municipalities?
Got it. Thanks very much.
Paul?
We're getting to the end of our hour, and obviously we didn't give you time to go play and then come back and talk to us. So let me just see if there are any other overarching questions.
I have a question. John, you had said that some of these are fixed and some of these are variable. How can you tell which are fixed and variable? I can't tell by looking at this.
Well, some have the indicator, the up and down indicators.
Okay.
Oh, I'm
See
sorry.
The button,
They all seem to have it. That's why I asked.
not below. See, mobile source strategies, they're fixed.
Okay.
I'm wondering if DVRPC did a survey or they're just assumed.
No, I should explain that those red numbers are simply the default numbers.
Okay,
And if you'll notice, if I toggle things a little bit, they should be the same.
okay.
So that those are not, those are just to tell you what the default numbers are. I would have put default numbers in the others, but there was no space.
So Henry, you know, I find this pretty exciting. And Neil, I like your embodied carbon question. But who built this, and has this been shared with DVRPC? Because I think a lot of this, for instance, public transportation, that's beyond the realm of possibility, you know, for one municipality, pretty much. I mean, I may be wrong on some accounts, but, you know, pretty much like rail transit. But I would think that, you know, has this been shared with DVRPC as a way to even fine tune an overall strategy?
Yeah, I developed this
Great.
based on the DVRPC material, and I sat down with them and
Good.
went through it. They appreciated it. It's beyond their mandates to work on, and we also discussed the ways of coming up with emission inventories more quickly than every 5 years, 3 years after the fact.
Yeah.
And they convinced me pretty thoroughly that that's a job. They put a lot of effort and thought into it, and it's not a quick procedure.
Right.